Hey guys, today we're doing absolute value inequalities. So we're going back to those compound inequalities we worked on earlier. So we have our and our ors. With absolute value inequalities, it's just like the absolute value equations where we're going to have two separate equations as well. Similar steps are just a little bit more complex with the inequalities. So what I'm going to do first, I'm going to write out the 4 steps we have to follow to solve these. And we're going to do 2 examples together. So the first one, just like the equations, we have to get the absolute value by itself. So get absolute value. So you want to get it alone on that side of the equation. So you're going to add or subtract numbers, divide by anything. You want it completely by itself. The second step is you're going to decide if it's an and inequality or if it's an or. So with our compound inequalities, we had that and or discussion. Remember, and was where you shaded the overlap, or is where you just consider anything shaded. So you've decided if it's going to be like that, and we have a little trick to do that. So when we read through it, we're going to say like greater and less than. So when we go through this, I'm going to kind of show you those examples of how to figure it out. It's kind of cheesy, but after a while, it makes sense. The third equation is you're going to write a compound inequality. Essentially, what you're doing here is you're writing out those 2 equations. And you're going to solve them. All right, so you're going to write the compound inequalities. And the fourth one is you're finally going to solve. And by solve, I mean you're going to solve for what x should be. You're going to do your number line, and you're going to do your interval notation as well. So it's a lot of steps, all right? We're going to refer back and forth to them continuously. So here's our first example. The absolute value of 2x plus 1 is greater than or equal to 5. So step 1, get the absolute value alone. Is the absolute value completely by itself on that side of the equation? Yes, step 1, completely done. Awesome. The second one is decide if it's an and or an or. So this is how you figure it out. If you read through the problem, it says the absolute value of 2x plus 1 is greater. So when I hear that word greater than 5, all right, greater means it's going to be an or problem. If it would say 2x plus 1 is less than, I say less than, it means it's going to be an and problem. So that's how I kind of distinguish between an or and an and. So since it says that the absolute value is greater than or equal to greater is an or problem. So now we decide if it's an or. Now we're going to write our compound inequality. So the first one's going to be just like you see it. All right. So the first one is the absolute value of 2x plus 1. Oops, we can get rid of the absolute values. My bad, guys. 2x plus 1 is greater than or equal to 5. The second one, just like the equations, you're going to flip the sign over here to -5. Now the catch is, usually when we flip the sign in absolute or in an inequality, what happens to that inequality? Usually when you flip it, aka you divide by negative, you change the sign. All right, so that's huge here. So make sure you're going to flip the sign, okay, and make the number or change the number to the opposite. So it was 5, now it's -5. From here, we're going to solve both of these. And remember, this is an or problem. So the first one, I would subtract the 1 over. So I have 2x is less than or equal to 4. Divide by 2, and I get x is less than or equal to 2. Over here, I'm going to subtract 1. So I have 2x is less than or equal to -6. I'm going to divide by 2, and I have x is less than or equal to -3. Now that I have those, I'm going to use my number line to help me figure out where I'm shading. I've got 2 and -3, so -3, 2. They both are going to be closed circles. And we can do our shading here. So it says x is greater than or equal to 2. It's a little bit smaller for us. All right, and the second one says that x is less than or equal to -3. Again, this is an or problem, so you're looking for anywhere that is shading. So I would say a solution could be from -infinity to -3 with a bracket because it's a closed circle, or a bracket 2 to positive infinity. So we're kind of bringing it all together there with our interval notation and our compound inequality stuff, all in one big problem. All right, let's do another example here. Example 2, we have -2 is the absolute value of 4x minus 1 is greater than -14. All right, step 1, if you recall, is to get the absolute value by itself. Is the absolute value by itself? No. All right, we have to get rid of this -2. So how I would do that is I would divide both sides by -2. So I'd have the absolute value of 4x minus 1. If you notice here, we're dividing by a negative. So guess what we have to do with that inequality sign? You have to flip it. Okay. So now, is the absolute value by itself? Yes, we're good to go. Step 2 is to figure out if it's an and or an or problem. So it says the absolute value of 4x minus 1 is less than, so it's less than 7. So this is going to be an and problem. Now that we figure out it's going to be an and problem, we're going to create our two inequalities. So the first one's what you see. 4x minus 1 is less than 7. It is an and problem. Then we're also going to have 4x minus 1. We're going to flip the sign and change the number to the opposite number. Okay, so we flipped and we made the opposite. Now we're going to solve both of these. So it says, I'm going to add that 1. So I've got 4x is less than 8. Divide by 4, I get x is less than 2. I'm going to add that 1 over, so I have that 4x is less than -6. Divide by 4, and I have x is greater than -6 over 4, which I can reduce that down to -3 halves. We're going to graph this on our number line to figure out where our shading is. Since this is an and problem, you are going to be looking for the overlap. I would say the -3 halves goes here. If you write that as a decimal, guys, that is okay too. I do not care. Both these are going to be open circles. All right, the first one we have is x is less than 2. So x is less than 2. The second one says x is greater than -3 halves. And again, for this problem, we're looking for that overlap. So the only overlap I see is in between those two values there. So I would say parenthesis, -3 halves, comma, 2 would be my solution. So any number between those two would be value. So that would work. One quick thing I want to kind of highlight for you guys. All right, if we have a problem that looks like this. So if you have an absolute value that is greater than a negative. So here's what I mean by that. If we have an absolute value, 4x minus 1, and it's greater than -7. Let's think about this. Remember, what types of answers are we getting with absolute values? With absolute values, you're always getting a positive, right? Because it's the positive distance away from 0. So isn't a positive always greater than a negative number? Yeah, so whenever you see a situation like this, your answer is going to be from negative infinity to positive infinity. Because no matter what x value you plug in there, whether it's positive or negative, the absolute value is going to make it positive. So whenever that happens, that's always going to be greater than a negative number. So I would say it's all solutions are from negative infinity to a positive infinity. You won't see that a ton, but just as a kind of a shortcut, it will definitely help you out there.